Okay, so in our last session, we take a look on the concept of persistent volume and persistent volume claim, and we did the NFS based persistent volume claim and attached with the pod, and we put some stuff where in the NFS directory, and we found that stuff inside the pod. And we also cover about the network part, means service part, how to make the, what is the concept of the service, cluster IP, node port, external name, load balancer, and the most important one was the headless service that is working with stateful set. So today we have to look the concept of, this is our agenda point for today. We have to understand the plugins of the network storing Kubernetes volume. We did these persistent volumes, but we only had PV and PVC attached with the NFS. And we have to look into the empty directory volume concept, host path volume, storage clause concept. So this is our agenda point. Moreover, we also have to take a look on the config map and secrets. And these are also our pending points. We will discuss. I will also like to discuss this point, port forwarding. And this is just for the testing purpose. Sometimes we need to do this. There is a concept of drain and cordon. So I will try to cover whatever we can do today. The Kubernetes certificates concept we need to understand. By default, all the components of the control plane are communicating with each other on TLS. So those certificates are locally signed by signing authority, certificate authority. So that we need to understand. We should know how to renew the certificate. And then upgrade plan, the diff command we tried, we failed. We have to do this. So I will start with the concept of plugins for the storing Kubernetes volume. Actually, when you have a cluster, so your cluster need to make the persistent volume storage. And there are two ways to make the communication to the persistent volume for the container running inside the pod. We did NFS based. For the NFS, we must have to install the NFS client on all worker nodes where your pod will run. Even on the master node, if some load you are diverting to master nodes. And it is directly making the communication with the NFS server. You know, NFS server is using ports 2049. That should be open from your NFS server, from your worker node to NFS server. And there are a lot of other storage providers, especially when you are working in cloud. So cloud is providing you file storage based storage that is expandable. Mean its storage is unlimited. Whatever you will store, you just have to pay. And cloud is providing block storage based concept, that is the hard drive of your virtual instances. And moreover, in the cloud, you can do S3 type of storage, like a concept of buckets. So these storages, to reach those storage from the cloud, you need container storage interface. This is the concept of container storage interface in the cloud is to provide the drivers and the complete mechanism of authentication to access those resources and provisioning of those resources in the cloud. If I just look into the CSI on the Kubernetes documentation, we can see a quick definition of container storage interface. There is no documentation, but it's a part of blog. Yeah, it's part of blog, so we can get some definition. So basically, this is a Kubernetes project. So initially, when Kubernetes design, so when you will go into cloud, if I also open in parallel, okay, let me just first take a look. Why CSI? So you just take a look on this document. You will get the idea what is the concept of CSI. And so this is a type of driver of whatever storage you want to access. For example, you have on-prem some storage like SAF for third-party vendor storage. So that vendor can provide you the CSI driver that you can embed into your Kubernetes cluster that can help to access that storage. Okay, so just take a look on this documentation, and we will do this practically when we will deploy our Kubernetes cluster on cloud. So our agenda is also to deploy the cluster on AWS, Azure, Google Cloud, and IBM Cloud. So you should know at least these clouds, how to provision the Kubernetes cluster. Okay, and for the volume, we discussed yeah. So this we cannot implement this today right now because we have to provision the cloud-based Kubernetes cluster. For NFS I did, but the part of NFS what I did based on PV and PVC. Persistent volume claim. These are mandatory. I mean, whenever you will set up the CSI, you must have to use PV and PVC concept. Okay, whatever storage you will use the PV and PVC if that storage is residing outside the cluster. But sometime you can access the storage within the cluster, and those storage are temporary storage. That concept is empty directory volume host path. These are residing on your worker node where your pod is running. So these are temporary storage, and this is not temporary. This is permanent. I mean, whatever directory you created on your worker node and you schedule a pod on some worker node. So that pod will directly access that host path from your host machine and will mount within the container. Empty directory is temporary. So we have to implement this. And there is a concept of storage class. At the end, I will clear this. What is the storage class used for? And direct NFS is also implementable. If I show you the documentation, if you don't want to use persistent volume and persistent volume claim concept, for NFS plugin, you can directly provision NFS from the container pod definition to the, or you can directly mount NFS with your container. For the container storage interfacing, whatever whatever driver you are using for CSI, you must have to use PV and PVC. NFS can also work with PV and PVC, but it can also directly be attachable with the pod. So let me just quickly start with the last time we tried to implement the PV and PVC. So if I go to this volume, and here I can see the whole list of this. So you can see these are all type of storages. So for that purpose, you must have to implement the CSI. There, like a your disk, a your file, a your file CSI. Your will provide you the complete documentation how to deploy the CSI. We will do this, but right now we are just interested to get the idea the self storage. So if I click on yeah, NFS based storage. So here is an example where pod, last time I used the persistent volume claim. But this type of pod is trying to connect. For example, if I deploy this pod, NFS direct pod, this pod is directly hitting to NFS storage. And I know all my worker nodes are able to reach to NFS because last time I checked that connectivity with the export FS command. Let me just power on my NFS. So this is a just test PD. Okay, it is using some image from Kubernetes registry. I would like to use a simple Nginx and name of the container test. And this is a volume mounting inside the Nginx. And I would like to mount under the USR share HTML, USR Nginx/HTML. And this is a webroot path of Nginx, and this is the test volume. And the test volume, last time we use here PVC, if you remember. So I shared this GitHub repository from Kubernetes. Here you can see a whole lot of manifest pre-configured. So last time I used this PVC. I create this PVC and this deployment. Last time we, this is NFS based, but we also use PVC based, persistent volume claim. So here we are using volumes. Directly we are defining NFS, but last it is not NFS, it is persistent volume claim. So you can, this is a type of storage you want to attach with your pod. So here I have to provide the NFS server IP or name. Here I have to provide the path of NFS storage. And read-only true mean the container cannot write anything in this storage. If you read only false, then container within the pod container can directly write to this volume. So it depends. So now if I use export FS, show mount. I can see last time I set up this DB2, DB1 PV. And I think I also put some stuff inside this NFS share. I will use this path. And it will be mounted under this path. So let me just quickly deploy this pod. Okay, it will not work because my environment variable for kubeconfig is not set. I have not made this persistent. If you want to make this export persistent, what you can do in the bash profile. I don't think so. Here I have bash profile. Yeah, bash RC I can use. Bash profile. Yeah, this is a profile. So whenever I will open any terminal, whenever I will log in, this environment variable will automatically be exposed. Okay, so now I will apply. Yeah, get pod. I want to see. Let me just delete this whatever I created earlier. I think I deployed in default namespace. Okay, it's running. And if I go to kubectl, describe this part. So in the description, you can see the volume is mounted from this server. This is test volume. It is mounted here from test volume and in read write mode. It should not be read write. I don't know why it is here, but let me test from within the container. So if I go inside the pod, and inside the pod, if I jump into this path, same content I can see whatever I created in the NFS last time. So this was some website we did, and if I do an expose to this pod, expose pod name, I don't want to type. I will use node port. Port is 80 and target port is 80 and namespace is default. So when I try to do this, cannot retrieve selectors. Okay. What is the problem? Actually, I think when I create this file, I think I have not defined any selector. There is no label. So there should be actually this was a sample file I took from here, and they have not defined any label, but yeah, under the template metadata, I can define some label. Think like this. I don't remember exactly. So any label I can say like app, NFS. just direct connect. I need to reapply this. Okay, now the label is defined. That label will be used as a selector for the service. So exposing this port, okay, in the default name already test port, okay. I think use it here, get SVC. I can provide a different name. I can say NFS port SVC. So this is exposed on this port. So if I go to my browser and try to access my worker node on this port, so you can see whatever content we put in webroot via NFS here, it is accessible. That website is reachable. If I hit to my worker node, that is IP2, that is also reachable from worker node 1 and worker node 2. So all are exposing this port. Okay, so we just test this. So if you don't want to use with the NFS, the persistent volume and persistent volume claim, you can directly provision this too. But the professional way is to use the persistent volume and claim. Okay, the next thing is this empty directory. This empty directory volume is basically, it's just like an ephemeral storage, you can say. Whenever the pod will be deleted, this storage will also be removed. There are some use cases of this empty directory too. I mean, sometimes you don't want to save data permanently, but you need some cache type of data. The example I can give you, just like the definition of, if I open this, when I gave you the idea of pod. So in the pod, there was an example, two containers were sharing the same volume. There was a picture, yes. So here there is inside a pod two containers. One container is writing data, the other container is reading the data. So this is a volume. This type of volume is not persistent. So you can use the empty volume for this purpose. So empty directory type of volume. The pod that defines the empty directory volume, the volume is created when the pod is assigned to the node. And from that specific node, some temporary directory is shared to this pod. And some uses of the empty directory scratch spaces such as the disk-based merge sort. This type of example I gave you. And two containers sharing the same data. Checkpoints along computation of the recovery from crashes mean you want to dump some dump that data that is not usable. You just want to dump some data at some location that is not that should not be persistent. And holding files that a content manager container fetching from the web server. This is again the same example. And there is one more use case that is not written here, but maybe defined here. When we will define this empty directory, so we can define a parameter of memory. And those, in the Linux, there is tempfs. There is a concept of tempfs. This tempfs is basically directly pointing to your memory. And the memory, and this is mounted to some location. So if you want to write some very huge data, very high speed data, so sometimes your disk, even your SSD is not able to sustain. So in that case, you have to write your data initially in tempfs, and then you can gradually move that data to persistent volume or wherever you want to move. So this tempfs is directly pointing or writing data inside your RAM, and RAM is, speed is the writing speed and reading speed is 1,000 times greater than disk. So we can also define this empty directory just like this inside the tempfs, and that tempfs will provide a very high IOPS. So this can be example, and your container can write some logs or some valuable information in tempfs, and then you can write some script that can gradually fetch that information and can write in some other persistent volume. So you can attach multiple volumes. One can be pointing to your NFS, and one is with the empty directory. So this can be a situation. If I look into the empty directory configuration, so this is a pod, and this pod is using volume. This volume name is cache volume. They mount the cache volume under the container with name cache. So whatever this test web server will run may be using this /cache to write something. Okay, so here I will create a situation like this. Yes, I can create, for example, okay, let me just copy this. So this pod, I can say, and here I will define, for example, Nginx, and name of the container I will also use Nginx, and volume mount will go under the USR share Nginx HTML, and I can say cache volume. Okay, this is empty directory, and its limit is up to 500 megabyte. If I just put the curly bracket just like this, and I'm not defining this size limit, it will store somewhere on your host machine, and it can utilize all the space if it is writing some cache data in this location. So it's good idea to implement the storage limit, and if you want to use the high IOPS, so you can take the leverage of this empty directory dot medium. Dot mean, and the empty directory is indented with medium. Parameter, and that parameter value is memory caps. Inside the memory. So now under the temp FS, it will take 500 megabyte and will mount here. So now I will, the scenario I can create like this, like one container is trying to write here and one is going to read. Okay, so if I create one more container in this and here image I use BusyBox. BusyBox container is basically a simple container that and you can provide your own command to run within the container. And I can say some compute data. This container name image is this, and it will mount the volume, the same volume under, you can say, emp and data inside the container, the same cache volume. So this container will write in cache volume at this location, and this container will read. But we have to use some BusyBox example too. For example, let me see. BusyBox is not there. With this way, we can provide some command and argument. So I will use a command like this. For example, I am doing echo and or I can do something like date, and it is writing the date output to temp data in some file index.html. So what will happen now, temp/data is basically pointing to some empty volume, and that volume is also pointing to this location. And when this BusyBox will run for, but I need to do this consecutively. So I need to write some loop, for loop. Just a minute, let me get some example for just like this. So I just want to create an example to create a container that will be a BusyBox container or whatever container that is generating some data, is writing in the same volume, and that is readable for the web server. So in the next session, I will make an example. I don't want to do R&D here. So now this type of container is also known as sidecar container. Okay, so sidecar container concept is that is helping the main container that is providing the service to the end user. So if I go right here, sidecar. Sidecar container in Kubernetes. Yeah, here is the example. That this container and this container. This is the main container and this is the sidecar container. And both containers you can see are using the same volume. This volume data is used by both the container. It is mounted under the OPT. Both are mounting under the OPT. And one container is writing under the OPT logs. And other container is, one container is writing the logs with this command. And the other container is just printing the log. This is an example, but in practical life, this can be quite different. But you should know the idea that how both containers can mount the same volume and they can read and execute the data. So I will create some example for this one. Okay, so we did the NFS direct connect. We have done the PV and PVC concept. Empty directory, I tried, but the loop concept is failed. So just let me show you the host path concept. The host path, if I go to this documentation, I just need to type the volume. This is empty directory, this is host path. So in the host path volume, what is happening, our host path is directly associated with the host machine that is running the pod. So here is an example of the pod. This pod is using host path. And the syntax is very simple, whatever path you want to use on your host machine. So if I change this manifest, on my host, it can be some directory, just like data on the root partition I will create it. It is a type of directory. And this will go under the web root of the Nginx. Okay, and on whatever directory it will be created, it will automatically create the directory, I think. Let me just copy this. host path field / data is not a directory. So whatever it is trying to schedule this on worker node 2, and worker node 2 does not contain this directory. So let me create this directory. Next time when I will schedule, I don't know on which worker node it will go. So that's why I'm creating on all worker nodes. Now it's running. So now if I go under the, first of all, I need to check on which worker nodes is running. So it's running on worker node 1. So it's mean whatever I will create under worker node 1 / data directory will be pointing to so there is nothing. So let me go in my worker node 1 / data. And here I will create some index.html file. This file is created. And now I will just see here. I can see this is populated here. So this is directly associated with the host, whatever host you have created. So in this case, there can be a cluster with a multiple number of worker nodes. So in that case, you cannot create the directory on every worker node. You don't know where it will be scheduled. You can instruct the scheduler to schedule this pod on that specific node. For that, we check the static pod concept. In the static pod concept, we directly assign the pod with the please mic mute. Ali, your mic is not muted. Please. Okay, so we check that scenario where static pod, we can directly assign the pod to some worker node. So there are other scenarios too where you can instruct your scheduler to assign that pod to that specific node. In that case, you can create directory on only that specific node. But the practical example here I can show you, this is my master node. And in the master node, in the etc Kubernetes manifest, And these are the manifest. And if I just show you some this etcd, this is a database manifest. So this is the pod, static pod running, and here in the at the end you can see it is using the host path. Create, you can use this type directory or create, it will automatically try to create. Okay, so these two volumes are created here. Its name is etcd certs and its name is etcd data. Here all your database data files are saved on the host machine. And where it is pointed, etcd data, if I see here, volume mounted, under the volume mount, etcd data, it is pointing inside the container to varlib etcd. And the certificate is pointing to etcd Kubernetes PKI etcd. So these two volumes are coming from the host path. And if I go to my host machine, that is my master node, so I can see all these certificates are preserved on the master node at this location. And if I go to this path, varlib etcd, this file contains this directory that holds all the database about this etcd database. All the data files are present here. So with this way, these directories are this data, whatever etcd database is saving key value based data, it is directly saving on the master node. Okay, it is not exposing the data to outside the cluster. So that's why our master node is important. We must have to preserve these directories. So this is a practical example. If you go to other manifest, you can also see this API server. I think it is also using, you can see how many host paths. This host path for the certificate, this host path for the certificate, and this is some others. These are all certificate related directories that are available on the master node that are then used as a mount point within the container for the API server. For the controller node, controller manager, it is also pointing, you can see a lot of directories, etc SSL certificate. These are all the certificate paths. This is the configuration file present, directly pointing to this name is kubeconfig, and it is going inside the cluster, inside the container with the kubeconfig. This one here, it is mounting within the container. So we can change on the host machine this configuration file. It will directly impact inside the container. So the concept of host path is very important. Sometimes you need to preserve data locally. Okay. And the concept of storage class, we have to implement this storage class too, because last time when I create the PVC, persistent volume claim I created. If I just check if I had some. Yes, last time I created these persistent volume in dev namespace. So whenever you will create, you remember one last time when I set up this persistent volume claim, it was in pending state. It was looking for persistent volume. And if I look into the persistent volume, I also create two persistent volumes. So then I provision claims, and those claim automatically bounded with the available persistent volume. So every time when you will create a persistent volume claim, you must have to create the persistent volume too. And this is very difficult job to manage in your practical life. So for that reason, the concept of storage class is available. Storage class will automatically provision your persistent volume. And that is a complete lab we will do, but so far we did this manually. So the storage class, when we will set up our persistent volume claim, so if I show you in the manifest of the persistent volume claim we last time created, here is a parameter of storage class. So that is empty, mean we don't want to use storage class. We will set up our persistent volume manually. So when we will define here storage class, it will automatically provision the uh, persistent volume for the claim. And with the storage class, we can use either the NFS or CSI drivers, whatever we want to use. So we will use NFS. Okay. So now our open item is we have to just do an example for the empty directory where one container sidecar container will write the data and the actual container will read the data on the real time. We have to do this practically in we will do a special complete session on this one. And the next thing today, we have to do one thing that kubectl port forwarding. Quickly, I will give you the idea how this will work, and then we will jump into the config map and secret. So for example, I am running a container. I'm running a pod under a dev namespace. Last time I ran this. Okay, please mute your mic. For example, I'm running this a pod in my default namespace. Okay, this pod is running, and I want to access this pod directly without exposing the service, just to test whatever is provided by this pod. So I know this pod, if I do a curl from my master node, I can see this web page is hosted inside pod inside this pod. But in your practical life, you don't have access to your worker and master node directly by SSH. Okay, you are using from your workstation machine to query to your cluster. tab is already open. I just need to open a new tab. So from here, I am querying to my Kubernetes cluster, and I don't know, I set the environment variable. Let me just check. So I need to reopen this MobaXterm. I will not use this one. I will use CMD. Use shell. So I can query to my cluster, and I can see get pod. This pod is working, but I am working from my Windows machine. I don't have direct access to my cluster. I cannot directly query to this pod on this IP, because this IP is only reachable from within the cluster. From my Windows machine, it's not reachable. Okay. So what I will do, this is not reachable. For this is only reachable within the cluster. So I want to just test this application, and I don't want to expose this application. I just want to quickly test. So for that reason, I can use kubectl port forward. And port forward from which pod, from app 10. And I know this container is using port 80. So on my this Windows machine, I will open some port like 8181 pointing to 80. Mean this 8181 port will open on my Windows machine. That will point within this pod, and in which namespace, this is a default namespace. I don't need to define that namespace. So now you can see on my localhost IP of this Windows machine, as well as all the IPs of my Windows machine are forwarding all the request 8181 to port 80. If I go to my browser and if I just type localhost, you can see I am directly interacting with my pod without exposing. I am doing a port forwarding by leveraging the API server. So actually this whole connection of port forwarding is managed by my API. I made the connection by API server. So my local IP, whatever my local IP is, all the IPs of my Windows machine are able to. So with this way, I can quickly check whatever is running inside or service is up or not. If this is a database container, I can directly connect with this database by making some port forwarding. So whenever you will make a connection, it will give you a message. Here you can see here the handling connection for 8181. But when I will do a control C, this is no more reachable, because this was the tunnel created by the API server on the spot for specifically to troubleshoot, to look into directly into this port. So this was the concept of port forwarding. And now Configmap. The Configmap is used to provide the configurational files and it will save the configuration files inside your etc data. The config map is an API object store non-confidential data and key value pair. The pods can consume config map as environment variable, command line argument, or the configuration files. Whatever configuration your application need to access, you can provide by the config maps. So actually, you don't need to preserve the configuration files every time you want to modify within your container. You can save directly in, you don't need to say modify the configurational files inside your container by every time by modifying the container using Docker file. So config map can help you to modify the file. Whatever you will define in the config map, you can mount as a volume inside your container. So if I give you an example, the config map, this is the manifest of the config map. So let me show you from here, the command line. kubectl create config map. So here is an example of the config map. You can provide a name of the config map. You can define some file reference, and literal value is just key value, just like an environment variable. And yeah, you can provide some file or some key and value based. So you see some examples given here. You want to preserve some configuration file from this path. This is a file. These two files you want to preserve. Okay, and this is the key value based. And so these are from this is some file that contains the environment variables. So I will create a very simple key value based config map. For example, I can say some application environment variable, and from value, for example, username, and another key value, I can say password. In the dev namespace, I'm saving this. So if I now query kubectl get config map CMR, you can also use the short form. In the dev namespace, you can see the app env config map is created and its data value is 2. 2 values are saved. So if I describe this config map, you can see the username is this value, password is this value. Okay. Now how I can use these as an environment variable in my container. So the example, this is the value, and to use inside my container, I will just create a simple manifest. Run. So this pod I created, now I need to modify. I can provide inside the pod the environment variable. So to provide the environment variable, the indentation value is in parallel to name of the container. So env I can define here. And under the env, I can directly define the environment variable too, but I want to fetch the name of the environment variable. I can say name of the environment variable, I can say username. And the value from Configmap reference the config map reference is basically providing the name of the config map I created. So what was the name of my config map? So here in this example, they created the config map with name game demo. So my config map was app env. And the value I want to fetch from and the key that I want to fetch from I want to associate, I want to fetch from this config map. You can see this data is basically key. The username is basically a key. And similarly, password is a key. And this is the value. So these are key and value based concept. In the example, they also mentioned key and value. So pass is key and this is the value. Username is the key and user1 is the value. So I want to use a username key that is coming from which config map? App env. This app env contains a key having username. And whatever the value of this key will be populated inside your container with an environment variable name username. You can define any name here, or you can just change the user. Okay, so this is up to you, whatever you define here. This is the reference of your config map, and this is the reference of the key. Similarly, I want to use the another variable password, and I know its value was pass. Yes, PASS key I used. So these environment variable will be fetched from the config map. I think I did the indentation issue specs env. Under the specs env, there is, I think, let me just check the indentation. Name and value from and name value from. config map reference, and then indented I think it should be like this. Specs.env. Specs.env. It's in parallel to the name. Yes, this is the my fault that I did the wrong indentation. It should be like this. It's in parallel to name, not in parallel to container. These indentation are very important to take care. Config map reference indentation is wrong. Yes, this will be like this. Okay, now it's created. kubectl get pod. Container config error. Let me just see the app env not found. Yes. So what is the problem? kubectl get config map. In the default namespace, I am trying to create the pod, and in the default namespace, config map is not available. It is available in the dev namespace. So this is also a very important concept. Whatever resource you are creating should be, if they are pointing to each other, they should be in the same namespace. So app env is in the dev namespace. So what I will do, just I will modify this manifest to be in the dev namespace. Okay, now resource is created. I can see this pod is created. It's running, and if I go inside this pod, -n. Inside this pod, I will run the env, and I can see the user environment variable is created from the config map. The password environment variable is created, and these values are fetched from the config map. So you don't need to preserve your environment variable within your manifest. You just need to give the reference of your config map. So this was the one example use case of the config map. The another one is we can preserve some configurational file inside our config map. And that configuration file, then we can map inside the pod every time when this will run. So here is an example. They created a config map. Config map mounted a data volume. Config map also used to be the part of the system without it directly for the port. Data other part of okay. And the config map. Let me just create a config map of some configuration file. So the configuration file of from the pod I will fetch. I think with the kubectl I can do a copy. Yeah, copy file and directories to and from the containers. So if I went to go into this container, and I know its configuration file is under etc nginx nginx.conf, and the rest of all configuration files are under this location. So this is the configuration file for my nginx, and it is running on port 80. So I don't want to use port 80. This is just an example. In practical life, this configuration file can be related to your application, whatever application you are deploying. So maybe for the dev environment, that configuration file is different. For prod is different. For UAT is different. But here I will give you example of modifying this configuration file of nginx by using the config map for different parts. So I need to preserve this file. Hmm. I think we have to write here pod name too. Source and destination is required. This is a syntax. I used this command first time. CP, I want to copy to this location, and no, I want to copy from within the container. And the syntax is some namespace. The namespace is f/. This is the name of the pod, and then this is the path, and then here. in the dev namespace, okay, just I don't know exactly what is the exact syntax, but I will use cat to this file. I'm doing this manually. So this is the configuration file for Nginx, and I want to change its port to some different port. I want to run this on 8080. Only minor change I did. Rest of all, everything is same. And now I will create a config map that will preserve this default.conf file. Okay, this default.conf file. I can say Nginx and config. And here I will define the file from file, and the example I can see, yes, from file. And from file, key is also available. So key mean the name of the file you want to preserve inside your. So I will save the name of the file with the, that will be, this is a key, and the file is available at the current location where I created. Let me check where I save this file. So under the dev namespace, I create a config map with this name that preserve this whole file content. This contain only one data. If I do a kubectl describe config map, so you can see this whole file is dumped into this config map, whatever configurations, whatever was written in this file. So you don't need to preserve your files manually. You can dump your file in your etcd database. So now this config map contains this configuration file, and this is the key, and this is whole the value. Okay, so now I need some example to use this config map as a file. This was the key and value based reference. So yes, this is the example. So when you will use the key and value directly, you will use the env. For example, key and symbol value, then it will be for the environment variable that is coming for config map, whatever we did. But in the config map, you need to define this volume mount section. Okay, so the config map nginx-config. So I will create kubectl sample app custom port nginx. In the dev namespace, yes, I created. In dev namespace, so this file I created, I will modify this file according to this example. I need to define this section. And it will come, volume will come in parallel to the name, and the volumes will come in parallel to containers. Okay, so volume mount, this is the name of the volume. I can say nginx conf. And where it should be mounted, if you remember whatever path I dig down from within the container, this was the path where I would like to see this config map complete data. So inside the container, under this path, read only true, okay, within the container, nobody can modify this. And name of the config map. DNS policy, okay, this is just so config map engine is config just to avoid any spell mistake. Config map is okay. So this config map will create a file directly under this path inside this container, and with what name? That answer is when we create this config map. When we create this config map, so we define the name of the file. If we can create this config map like this too, then it will simply dump this whole file. In that case, you must have to define here the file name too. Okay, but in our case, we define the key as a file name. This is a good idea. You must have to define the file name as a key, and the value of the whole file is given. So let us now try to run this pod. I think it should be in the dev namespace because it will, yes, it's under the dev namespace. Because the config map is also under the dev namespace. Under the dev namespace, custom port Nginx just ran. And what is the IP? Custom port Nginx IP is this. If I do a curl to this IP, it will not respond me because this container config file is updated to port 8080. Yes, this is responding. So now if I show you the description of this port. Description of this pod will give us the information about the mount points. And this mount point, this directory is mounted by this config map. And this is the config map, and this is the volume, and this volume type is config map. Okay. So let me get into the container and see either our file, we verified from this curl. It is guaranteed that our file is updated. So I will just quickly jump into my container. Path was etc nginx confd. And here you can see this file is created, and it is pointing to some soft link. It is a soft link, and it is mounted somewhere else in this container, but it is available here. If I just do a cat to this file, you can see this file is updated one with the modified values coming from the config map. So this is a very simple example, but in practical life, for every application, you need to create a config file, and you need to discuss with the developer what configuration changes you need. So this will save your time of building multiple images. Every image, if you have multiple application with same image, but minor configurational changes in the configuration file for different applications. So you don't need to create multiple images for every application. You can use the config map mount for different application. You can create a multiple config map for each application, and you can use the same image by mounting the different config maps. Okay, so this was the idea how config map is working. Now our remaining topic is secret. So we will do this tomorrow. So tomorrow we will start at 9 a.m. Your time 11 a.m. And tomorrow we will also look into drain and cordon. Any questions?